Hello everyone, we're going to do fire protection systems part 2. So I hope you are ready for this. We're going to get started on this. And the best way as we talk about protections of occupants or protection systems is to protect our occupants. And know that there is a fire, and as early as possible we need to make sure that we notify the occupants are there. So how do we do this? Most common systems rely on the detection of heat and smoke. We know a heat detector and a smoke detector. But there's been so many advances in technology where detectors can be programmed to do many things. Of course, we have continuous updates to codes and standards in the addition of the NFPA 72, which is the National Fire Alarm Code and Signaling Code, which provides minimum performance locations, installation, and maintenance requirements for detection systems. So we're going to kind of go over some of those a little bit later. So we have detection systems. They may be carbon monoxide systems, smoke detectors, heat detectors, manual fire alarms, visual and audible alarm systems, voice communication systems, accessible warning systems, emergency alarm systems, and extinguishing systems. We're not going to go over in this part emergency alarm systems and extinguishing systems. That will be in part 3. So let's kind of break it down. Let's talk about smoke detection. Smoke and toxic gases are the main killers that these systems, so that's why these systems are important in every design. Smoke detectors detect smoldering fires that do not produce maybe enough heat to activate the sprinkler system, but we need to know that it's going to be combustible and it's going to be growing, so it indicates when there's smoke. They're used, smoke detectors are kind of used in two ways. They are wired to act individually or as a group, which is referred to as multi-station, meaning it can signal one area or the entire building. You will find in a residence like all of them are connected together, and most are connected with smoke dampers to close off airflow throughout the building or automatically close off rated doors throughout the building, which you'll see later on an example of a video when you watch it. Codes specify when smoke detectors are required based on evacuation needs or building types, including, of course, sleeping accommodations. Sleeping accommodations, of course, would be your homes, or it could be a hotel. Examples, of course, high hazardous, both residential occupancies, high-rise buildings, and ambulatory health care facilities. Codes does not state where to locate detection systems within a space, but NFPA 72 gives requirements of spacing with larger spaces. So let's talk about the NFPA 72 and 90. I want you to kind of take time to watch these videos to have a better understanding. So you might click on it and then kind of come back to the video. There was lots of changes that took place from 2012 to 2016, so the second video will kind of show you that. And then NFPA 90 really specifies the location of smoke detectors and the ductwork of air distribution systems. You'll find out, and later on you're going to learn a little bit about how the MGM Graham Hotel, how that kind of came to be in Las Vegas because of the smoke and toxic fumes went all through the ductwork. So take time to look at the videos and then log back on and get back into here. So where do we locate smoke detectors? We don't want to cram it right in the corner. That's not necessarily good. So a lot of times you'll find at least 4 inches or so off of the back of a corner is better. Not right in the corner on the wall. You need to lower it down. So a lot of times they say at least 12 inches down is not good. 4 inches is okay. So that's kind of where you want kind of a rule of thumb. put in here the beep and where you sleep, because that's one of the things the NFPA and FEMA government is trying to be pushed, that we try to make sure every bedroom in every home has a working smoke alarm. Smoke detector examples. Detectors are also known as initiation devices because their activation initiates the rest of the fire protection system. As I said, they're required to be hardwired together and a battery backup, so when the electricity fails, they can still go off. They're required to be looped together, so if one goes off in a home, the others automatically signal the alarm system and all of the other detectors go off. In general, there are different types of detection systems depending on the type of fire. Most fires release, of course, heat and smoke, but sometimes you may have a liquid fire that causes a drop in temperature instead. So, kind of, how does the heat detection work? This is an important type of detector because it detects sensitive to any change in temperature, especially, remember, if we have liquid fires where a drop in temperature occurs. So, if you see the example on the right, the visual, it's sensitive to that, and the thermistors that decrease in resonance as the temperature rises. You can see it's sealed and protected from the surrounding temperatures while the other is exposed. A sharp increase in temperature reduces the resistance in the exposed thermistor, which allows a large current to activate the detector's alarm. So a lot of times you will find, especially in commercial buildings, that this will be required. Manual fire alarms. You've seen these, I know, at a lot of your schools and other places. Code considers manual fire alarms to be a part of the detection systems. If an automatic smoke detection system or sprinkler system is not provided in a building, the codes typically require a manual fire alarm. Certain, of course, occupants require both a manual fire alarm, smoke detection system, and or a sprinkler system. Examples would be educational occupancies, assembly, and business occupancies. You can see, of course, the white T-bar. All you have to do is go by and pull it down, and all the fire alarms, and a lot of times it's connected to the fire department, and it will go off. The key there is for you to reset it. So, manual fire alarms, when they're required, they're typically required to be located adjacent to the entrance of the exit doorway. You can see the visual on the left-hand side, and it's also located in your textbook. The alarm box should be easily seen and located on the latch side of the door, no farther than 5 feet from the doorway. In hospitals, boxes are typically located at control rooms or nurses' stations for use by staff. And the travel distance to any alarm box typically has to be within 200 feet. So when you're planning out a facility, you may need additional boxes so that they can be used. This is what one looks like. I need you to also look at the IBC 907.4.2, and it talks about the location and also minimum heights of 42, maximum 48 inches. The color is typically in red, and you can see, of course, there may be other colors, but that mainly is not approved in a lot of jurisdictions. Alarm systems. They make, of course, of occupants aware that something unusual is occurring, normally to warn occupants that a fire and they should evacuate. It can be also used to notify other types of emergencies, such as toxic spills, severe weather, or a bomb threat. Today we have to determine the type of alarm, its location, and the wiring that is required. NFPA National Fire Alarm and Signaling Code gives those details. Now, most designers, of course, are not going to be laying out some of this, but you will be working with alarm system companies, and you want to make sure that you know enough about the information that you'll be able to make sure that you don't plant something in the location that alarm needs to be located. Sometimes alarm systems are referred to as notification appliances. This is important to kind of know. Alarm systems can be activated manually or automatically by a detection system or automatic sprinkler system. So there's kind of differences in alarm systems and how, of course, they may be put in. Now, all of this is based on your occupancy classification. You may have a single station alarm. That means the sounds only within the area the fire is located. Warns the occupants in the immediate area. Or you may have a multiple station alarm. It is a system of fire alarms that is interconnected so the indication of fire anywhere in the building will sound all of the alarms within the building and trigger a total evacuation. But you're going to find out sometimes there may be particular zoning in large occupancies. That means they may start at near the doorway and start getting the rest of the people, so there's a flow to get everyone out. It's interconnected, but the alarm goes out in particular zones. And normally the local fire department is notified as soon as the alarms go off. Now you have visual and audible alarm systems. Audible, of course, signals emergency by a very loud sound. And you'll find in the IBC code book, it tells you, of course, the decimal of the sound that it needs. It may make a single loud blast and a pattern of short blasts. Alarms place in a natural path of escape at each required exit, so the noise from the alarm helps occupants to locate the exit. The visual alarm uses a strobe light or rotating beacon. The strobe usually emits a pulsing light that can not be ignored is intended to awaken occupants who are sleeping. Normally it's a white or clear flashing light. And you can see the ADA has the ICC 8117.1. So read in the IBC code book section 907. Now I've also put a video link which is a great just 2-minute example of how all the audible and visual alarms work. And you will notice, of course, how the doors automatically close if we're going from one type of hourly rating to another. So we're trying to compartmentalize certain areas. You also notice that the exit signs will flash. So make sure you watch the video. Then we have emergency communication systems. Some require building types to have an emergency communication system that's tied in with a fire alarm system. And FPA 72 defines it as a system for the protection of life by indicating the existence of an emergency situation and communicating information necessary to facilitate an appropriate response and action. So what it's saying, it's voice communication. Now, there's different types of buildings that require that. Factories, institutional occupancy such as hospital, assisted living, large storage facilities, high-rise buildings, some assemblies, and hazardous occupancies. So this kind of, what they do is sometimes you may have to notify or let people know that one particular exit is totally blocked, and it allows you to be able to communicate with the people within the building so that they can go through and exit in a safe manner. Paging, zoning, create within the building. The codes allow the system to be used for other announcements as long as a fire alarm takes precedence over that. You will find that there are accessible warning systems. Code, of course, our ADA code requires an appropriate system to be provided with the occupants with disabilities. Sometimes you'll see tactile notification appliance where things vibrate sensation so that people will, a large number that are seeing impaired or hearing impaired, like in a special school or a dormitory, may see this and they feel it instead of course, hearing and to kind of go through. So visible test messaging systems are used. So I hope you've enjoyed this like a quick video. Go back and look up the PowerPoint and click on the links and watch the videos that are within.